Okay, let's develop the idea of a velocity vector. This shouldn't be much of a surprise, I think. So, if you had a position function, so I'm going to think position as a function of time, probably. Okay, so if I had position as a function of time, how would I get velocity?
Take the derivative.
Change.
Yeah, I want to take a derivative, right? I want to know about the rate of change of position, which is going to be velocity, right? Okay, so mechanically I'm running into some issues, right? Because I don't know how to differentiate things like this. You guys all see that?
Can you just do velocity at one time minus the velocity of the initial one?
Divided by time.
Oh, perfect. Yeah, so if I wanted to develop this, right, I'd write, okay, v of t, that's probably, what?
Change in distance over change in time.
Okay, so it might not be exactly, but it's about, right? Change in position divided by change in time. That seems like it makes sense, right?
Yeah.
And then how would you get actually v of t?
dp over dt.
Okay, you'd call it dp over dt, right?
Or did you want us to do like the limit?
Well, but I don't know how to calculate this object, right? Like, right now this is crazy talk, but it's definitely a good notation for this. I could also call it p prime of t, right?
Yeah.
But where would you get that? Like, where's a formula for that? How could I?
As the change in t goes to 0.
Perfect. Limit delta t tending to 0 of
T minus, sorry. Oh. T
minus t. It's a long form derivative.
Yeah.
perfect t plus delta t minus p of t, right? The change in p divided by
Divided by t.
The change in t.
Change in t.
change in t. Okay, so this is like just rewriting the limit definition of the derivative, right?
Yeah.
You guys see that? I haven't really changed anything here, and I'm not really going to change anything here. So, let me rephrase this so we can see that I'm not changing anything. What if p of t had some coordinate functions? Like, what if that p was x as a function of t, y as a function of t, and z as a function of t? Then how would you write p prime or v or whatever? So v of t, which is p prime of t, that should be the limit as delta t tends to 0 of what? What should I put in the limit?
X of t plus the change in t.
X of t plus x of delta t.
X of t plus delta t,
And then y times
y of
t plus the change in t.
t plus delta t,
And then the same for z.
z of t plus delta t.
And then it's just going to be minus
And then I'm subtracting
the x of t.
x of t, y of t,
Z of t.
z of t. And then all this should be divided by change in t. Okay, so hang on, we just threw a bunch of symbols up here, right? What is this minus sign?
Difference?
That's subtraction, right?
Yeah.
What am I subtracting?
The d starting.
You're subtracting the initial value.
This is kind of the Yeah, I'm subtracting the kind of initial position from the last position, right?
Yeah.
But categorically, what object is this? Is it a, oh good, it's a vector, right?
Yeah.
You see that? So I'm doing vector minus vector. So this is vector, yeah, subtraction
Subtraction.
or addition,
Yeah.
right? That's really vector addition that's happening there. What's this long fraction bar? What's that thing talking about?
That would be vector multiplication. If you're trying.
Close.
Scalar.
Scalar,
That's
yeah.
scalar multiplication. You guys see that? Really, I'm taking these two vectors, calculating their difference, and then I'm multiplying by the scalar 1 over delta t. I just want to check that I'm allowed to do all that, right?
Yeah.
You guys see that? So because delta t is a scalar, I'm okay doing this. If delta t was a vector, I wouldn't know how to do this. You guys see that? Okay, so let's do that vector addition. I think you guys know how to do that. So I'm still looking for p prime of t, right?
Yeah.
Okay. So how do you do vector subtraction?
Vector subtraction.
Yeah, like what do you get when you subtract this vector?
You're
Or
just
that
gonna-
vector from this one?
You're just gonna get x of t, just group like, yeah, like group
Oh yeah, just group like terms, right?
corresponding.
Like the x components of the vectors, right? So I'm going to get x of t plus delta t
Plus x, oh no, minus xt.
minus x of t,
And the same for the others.
and then y of t plus delta t minus y of t, and then z of t plus delta t minus z of t. And then all this jazz is supposed to be
Divided by delta t.
divided by delta t. How do you do that scalar multiplication? What do you get?
Goes in each term.
Good. Goes into each term, right?
Yeah.
Oops, I lost a limit. Did you guys see that?
Yeah.
I really should have here.
Limit is.
Limit delta t tending to 0.
Yeah.
So now I should have limit delta t tending to 0. And in my first component, what do I have?
X. Yes, x.
X of t plus delta t minus x of t all over delta t. Cool. What's that look like?
The original derivative.
Yeah, that looks like a one-dimensional derivative, right? You guys see that? Okay, and then in the y slot, what have I got?
Look at the same thing.
Same thing,
Only
right?
x is y now.
Y of t plus delta t minus y of t over delta t. And then in the z slot,
Same, only now y is z.
same thing. Z of t plus delta t, comma z of, or minus z of t over delta t.
Well, if you distribute it out, you're gonna get rid of your x of t's and y's of t's. And
Careful.
No, you're not. Never mind.
So why can't I say that this first bit is x of t plus x of delta t?
Or operations.
Going from.
Yeah, because of order of operations, or because x isn't necessarily a linear function, right? Okay, so next step. What do you get? What's the,
That's a vector.
yeah, you get a vector, right? There's three things.
Set it equal to 0.
No?
X prime of t plus change of t.
How about just x prime of t?
No.
You guys see that?
Oh,
Right, because if I take the limit sending delta t to 0 of this stuff, what do I get? Well, that's the difference quotient for x, right? So I get x prime. What do I get in the y slot?
Y prime. And then you get z prime.
Y prime and z prime. Cool?
Yeah.
So if you want to differentiate a vector value function, right, or a parameterization, how do you differentiate?
Just do the derivative of each portion.
Yeah, just do the derivative of each piece. So here's your velocity vector, right? V of t.
Then would it
And
be
really we should say something along the lines of, remember we started this saying if p of t is x of t, comma, y of t, comma, z of t.
then would we just do the second derivative for acceleration?
Ah, yeah. You want an acceleration vector, where do you get it?
Just do the second derivative.
Yeah. Just take the second derivative in the exact same way, right? Cool? Questions, things? Alright.